Okay, should be live. We should be live. 1 2 1 2 1 2. Where's my audio feedback? Okay, should be live. Okay, there's a delay, but that's okay. At least we're using the correct microphone, so that's fine. Yeah, testing a few tools on BioniChaos.com. Apparently, the gesture groove is the most successful so far, even though it's not quite biomedical related. But we have new prompts. We have new prompts for development. The expert developer essentially sitting in a prompt. Yeah, this one's doing like a false detection of a hand. So you have still the two scales. So we did quite a few videos about it. In the past we can get a bot to explain it. Actually get we will get do you rename it shit? And let's check, we should have passed. Its search is not quite good. It's not quite correct, I think. It's funny that Google meant to have a real good search, but it seemed to have trouble searching its own stuff. Anyway, we'll give it the link to. Wait, we had a prompt for that as well. Last time we did hollow face. That was the last one we covered. Can you, in addition to describing the tool, talk about false detections? So currently it seems that my hand is being detected where my ear is. So it should be a simple fix because it's happening all the time. And also, can you also cover the demo mode? We're having some issues with the demo mode starting when, so it meant to be starting when the user is not interacting with the page, but then in this particular case, the interaction is moving your hands on video. So essentially, maybe when it's generating audio, it should not start the demo page. Can you explain if that makes sense? If that makes sense. It's a flash model. Thinking, not sure if it's thinking or not. Yeah, imagine this, imagine that, but that's okay. It's better than when we turn this. yeah, so everything do is available on BioniChaos.com. Go check out this site. We have a bunch of new tools at the bottom of the page, and we are testing all the tools. So this one needs some work. So this one's playing music. We'll review it by AI. It will do a better job explaining it. It will do a much better job. I'm meant to be mouth modulator and 2 hands. So you're essentially playing like 3 instruments with your mouth and 2 hands. But we're having some problem. We have this false detection happening on the ear. The mouth is working fine, but the label is not very visible. So we need the potentially better visualization for the mouth. The hands are working fine, I think. And you can select your type of sounds for the left and right hand. There is latency issues with latencies. So it's kind of if you're moving your hands too fast, it's kind of lags behind. So there's a few things to improve. We'll see if we'll see what the current flagship models can do.
Imagine turning your raw body movements into rich, multi-layered electronic music using nothing but your webcam and a browser window. That is exactly what Gesture Groove achieves on BioniChaos, mapping your physical landmarks directly to dynamic frequency fields to create a live, spatial audio sandbox. By tracking 21 precise coordinate nodes on each hand and your mouth's changing aperture via cutting-edge computer vision, it translates your gestures into linear pitch scales, continuous gain adjustments, and automated sound envelopes in real time. But how far can we push this browser-based, zero-latency physical modeling framework before the boundary between human intention and algorithmic interpretation begins to blur? Right now, a particularly amusing quirk in the spatial calibration illustrates this challenge perfectly, as the system is frequently mistaking ears for hands and triggering accidental synth frequencies when someone is simply sitting still. Because this false detection happens so consistently, it points to a straightforward fix in the underlying landmark confidence thresholds, ensuring that only genuine hand geometries ignite the oscillators. A similar optimization is underway for the automated demo mode, which is designed to engage when the page is completely idle to showcase the synthesizer's capabilities. Currently, the demo mode mistakenly triggers while the system is actively generating audio from video-based hand interactions, so the logic is being refined to recognize these continuous data streams as active human engagement and stay paused until the performance truly stops. Did you know that all the tools we developed live are freely available on link to BioniChaos.com? There is always a real human in the loop if you have any questions, ideas, or feedback about BioniChaos, so we invite you to head over to the site, experience the interactive sandbox for yourself, and drop a comment to let us know how your gestural music performance sounds.
Right, so yeah, that was a pretty decent explanation to what's going on. We'll actually use that second paragraph as a prompt. Yeah, everything we do is available really on BioniChaos.com, so you can check it out. Okay, this one's called Gesture Groove, and we'll get one of the flagship models. I don't think it really matters which one. I think we will put the so this is Gemini 3.5 Flash, most intelligent model for sustained blah blah blah, thinking level. Let's actually do AI for that because it's also the recommended one. So it might take a bit longer. Yeah, so the demo should, so there's two problems. There's a false ear detection. While you edit, maybe improve the user interface, we're essentially trying to potentially prevent the vertical scroll bar on the settings. You can check the image to see what the problem is. Yeah, so we have the code is 13,000 13,000 tokens. We have the prompt. Just fine tune it a bit. It's in high thinking mode. Do we, then the question, do we need to ground with a Google search? Maybe we'll do that. Yeah, that's the demo starting essentially too soon. And should we let it work or go over the thinking?
Okay, I'm diving into the HTML file. My focus now is dissecting the code, especially the tone, JS, media pipe integrations, and the structure of the gesture music generator and the live spatial audio sandbox. I'm breaking down how these components are working together to achieve the final outcome.
Okay.
I'm now zeroing in on the image and its associated problems. Specifically, that troublesome, false detection bug keeps coming to mind. I've realized pose is indeed initialized, despite having no on results, and that hands are key. I'm checking the code's data flow, trying to ascertain how hand detections might be incorrectly triggering synth frequencies. I'm now focusing on the ears for hands misidentification issue. I'm exploring the media pipe hands configuration, specifically the min detection confidence and min tracking confidence values. I plan to increase them, aiming to filter out false positives. The demo mode bug, which triggers incorrectly, is another point I want to address next.
Okay, it seemed to know what it's doing, finalizing the display, adjusting dimensions, finalizing CSS, revising dimensions, adjusting the button, blah, blah, optimizing the layout, okay. Okay, let's just read the output. Okay, so it did a bunch of things.
Raised the min detection confidence and min tracking confidence options of the media pipe hands instance to 0.75, up from 0.5.
Okay, let's just test it. So the code is just a bit longer. We'll go for local server. Where's the camera? It's requesting a button processor. Oh, right, I forgot. Right, no, it's actually working. Okay, let's test it real quick. Yeah, there used to be a problem with the ear doing false detections. Yeah, the muff is still working. The ear is not being falsely detected anymore, so that's good. Let's test the hands. So the ear is not triggering the sound anymore. The mouth modulation still. Yeah, the user interface is better as well. Yeah, it got rid of the scroller, the vertical scroller, so that's nice. Ah, that's really annoying that the button can be pressed. Logging events below the viewport. Okay. Okay, just another thing. Okay, just another thing, considering we are in dark mode. The mouth modulator animation is currently these black dots. Can we potentially improve it, make it more prominent so it's actually clearer that the mouth modulation is doing something? I mean, when it's doing something, we can hear it as well, but we like the visualization to be clear as well, because currently it's kind of too dark. Oh, and we haven't tested the demo mode starting. It meant to start by itself at some stage. It meant to start by itself. Hey, we probably need a demo button. We actually have it in the new developers prompt. We have it in the new. The demo doesn't start at all. Interactive stream, how to reset demo. Wait, let's read that real quick.
Raised the min detection confidence and min tracking confidence options of the media pipe hands instance to 0.75, up from 0.5.
Okay, so supposedly that's what fixed the false detection of a hand on my ear. I don't know if my ear looks like a hand or is it a problem for everyone else. What else?
Added a validation check inside the onResults function that verifies the prediction score of the identified handedness data score. If the confidence score falls below 0.8, the coordinate data is skipped. This prevents facial features, like ears, and background noise from being erroneously interpreted as hands.
Okay, that sounds good. Okay, now with the demo mode, made some changes to the demo mode.
Added calls to trigger activity inside the live data stream handlers, on results and on face results. When coordinates are actively being processed, the inactivity countdown timer is continuously reset. This prevents the automated demo mode from initiating while someone is actively performing in front of the camera.
Actively performing. Yeah, I'm actively performing in front of the camera. But wait a sec, let's actually... Let's turn the camera off for a sec and see if the demo mode is actually starting. Yeah, I'm more inclined to remove the automated demo mode start, just have it as a button, especially in this, for this application. Yeah, the demo mode is not starting. The demo mode is not starting. The demo mode is not starting.
Play.
The demo mode is not starting. The demo mode is not starting. Wait a sec. Okay, currently we're still having trouble with the demo mode. So how about we remove the automated demo mode start and just use a button instead. So we have a demo toggle on off button and remove the automated start of the demo when the app is idle or something, because that's not working at the moment. The AI Studio has this interesting speech to text. It's actually recording your text and then it's obviously doing something to it, because it's kind of seem to be potentially better. Yeah, I'll read the speech to text real quick.
Okay, just one other thing, considering we are in dark mode. The modulation animation is currently displayed as black dots. Can we potentially improve it, make it more prominent, so it's actually clearer that the modulation is doing something? I mean, when it's doing something, we can hear it as well, but we'd like the visualization to be clearer as well, because currently it's kind of too dark. Currently, we are still having trouble with the demo mode. Remove the automated demo mode start. Use a button instead. So, Have a demo toggle on, off button and remove all the automated start of the demo when the app is idle or something, because that is not working at the moment.
Okay, and I'll go over the thinking process real quick. It's really long. Yeah, we have a high thinking level at the moment.
I'm currently focused on the modulation visualization, specifically how face landmarks are being represented. Right now, it's just black dots, which feels a little simplistic. My next step is to explore more intuitive and informative ways to display the modulation animation, potentially incorporating color or other visual cues to improve clarity. I've been examining the code more closely, and it seems the landmark representation, initially described as black dots, might actually be a dark green color, specifically number 04B. I'm now diving into enhancing the visual feedback for mouth modulation. My plan is to move beyond the current dot representation. I'm leaning toward glowing outlines, pulsing rings, or neon lines for landmarks.
Okay, we'll see what it does.
I'm now zeroing in on the best visual enhancements for mouth modulation.
Okay.
I'm now implementing the code for glowing outlines in the oral region. I'm focusing on lines connecting key landmarks with...
Okay, so it's doing that, refining demo control logic. Okay, how about that? Okay, how about we just test it instead of... Wait, it didn't generate... No, it did generate the code.
Brightened and glowing modulation visualizations. Canvas variable bug fixed. Standard HTML5 canvas contexts do not natively evaluate CSS variables, like var, miradors2, causing them to fall back to black, rendering the dots invisible on a dark canvas. All canvas colors have been replaced with direct hex, RGBA values, e.g., number 04BF68 for green and number 00FFAA for cyan. Connected mouth mesh. Added an active, connected polygon overlay representing the user's lips. When the mouth opens, a semi-transparent cyan glow, RGBA, 0, 255, 170, scales its fill opacity dynamically based on the modulation depth. Expanding sonic ripples spawned glowing green wavering animations centered at the mouth coordinates when modulation triggers, normalized mouth greater than 0.25. These fade and expand outward smoothly over consecutive frames. Simplified demo mode with dedicated toggle button. Auto start removed. Removed all inactivity timeout parameters, idle check functions, and manual activity interaction listener chains. Demo button added. Added a clean, demo playback, off, ON, button to the control sidebar immediately below the reset simulation button. This enables direct, manual control over the sandbox showcase loop. Sidebar scrollbar resolution. Set overflow Y, hidden on the desktop viewports for viewport sidebar to completely eliminate the scrollbar visible in your screenshot. Compacted desktop padding, margins, and component heights, such as reducing option pills to 36px, so all configurations fit into the workspace layout on smaller screens. Preserved full 48px sizing and natural vertical scrolling within the mobile at media queries to keep touch interactions friendly on phones and tablets.
Okay, it's better in terms of visualization. So we still have the... do I have the how to use? Okay, a couple of things. Can we make sure the text at the bottom of the page below the canvas is updated and expanded? Now in the the demo mode is weird at the moment. The demo mode is not doing much. Supposedly the hands are moving. There's no line for the distance between the thumb and the index finger. So we would like to, have a more expanded demo mode showing all the features that we have. Yeah, we still have a false detection of a hand on my face. The ear is not being falsely identified as a hand anymore, so that's better. Yeah, so the demo mode currently, yeah, it's very poor. It only has the hands moving. The sound is not actually corresponding to where the hands are, so on and so forth, so you know what to do. Another minor thing, last thing, is the tick buttons are badly implemented. I have to actually click, so say the... Okay, there is a bad false detection of... I think it's left hand on my face. So I don't know if it's... why is it happening? It's only happening when my face is blurred out. Not sure. Maybe we'll do... yeah, it's only happening when my face is blurred out, which maybe is okay. Maybe just leave it for now. Leave it for now. Yeah, the overlay video feed and log events below viewport, the toggle tick box buttons are annoying because I cannot actually click on the... I cannot click on the actual tick box to toggle. I have to click on the text. So it's something with the styling of the page, I assume. Can we fix that as well? The mouth modulation is working. Okay, that's off. Synth, FM, AM. Duo. What's the duo doing? Not sure. What's the duo is doing? What's the duo is doing? Okay, we're still going with Gemini 3.5 Flash. It's actually changed our prompt into bullet points, which I didn't ask for, which is a bit weird.
Can we make sure the text at the bottom of the page below the canvas is updated? Can we make sure the text at the bottom of the page below the canvas is updated and expanded? The demo mode is not doing much. The hands are moving, but there is no line for the distance between the thumb and the index finger. We would like to have an expanded demo mode showing all the features that we have. We still have a false detection of a hand on my face. The ear is not being falsely identified as a hand anymore, so that's better. The overlay video feed and log events below the viewport toggle tick box buttons are annoying because I cannot click on the actual tick box to toggle. I have to click on the text. So it's something with the styling of the page, assume. Can we fix that? Key modifications made. Double-layered false tracking face bounding box filter. Hand detection on the face is now neutralized. During active face mesh tracking, the code mathematically constructs a relative bounding box, minx, max, mini, maxi, containing the face region. In on results, if a hand's wrist coordinate enters this bounding box, it is identified as a false positive, such as a cheek, ear, or nose structure being misidentified as a hand, and is discarded. This protects tracking accuracy while leaving genuine hand gestures outside the facial zone untouched. Fixed the annoying double toggle checkbox bug. The container rows were updated to native, standard less than label greater than elements linked to their respective inputs. Removed manual state flipping JavaScript, CHK, checked equals. CHK, checked, which was previously conflicting with the browser's native checkbox selection events, resulting in an annoying double toggle glitch. Clicking either the checkbox or the text now changes states on the first click. Rich, expanded visual and acoustic demo mode. The manual, demo playback button has been preserved, and all automated, idle timer interruptions have been completely removed. Visual extensions, simulated hands now actively render moving thumb and index finger nodes, complete with green connecting distance lines that scale dynamically to represent pinch modifications. Mouth mesh simulation, the demo mode now draws a floating lip mesh that opens and closes dynamically. Simulated modulations, when the simulated mouth opens wide, the demo triggers glowing green sonic ripples propagating outwards. Synchronized audio triggers, when sound is enabled, the demo mode dynamically generates pitch outputs on the active left hand, right hand, and mouth instruments, matching the visuals on the screen. Updated and expanded bottom documentation. Fully expanded the content blocks to explicitly explain the new features, manual demonstration loop, canvas hex implementations, and face-hand isolation mechanics. Demonstration sandbox loop, lacking a camera feed. Toggle the manual, demo playback button. The system will simulate dual hand pinch distance alignments, facial lips tracking loops, and synchronized note outputs automatically.
Okay, let's remove the we'll do I think level minimal. Remove grounding with Google search, and we just want to answer a few quick questions, and I forgot what they were. Oh, can you describe the demo mode? Currently it seemed to be doing only the mouth modulation in demo. Can you quickly check that? Pretty sure it's only doing the mouth modulation. Or the mouth modulation is like overtaking everything else. Why is it rewriting the code?
Checking the configuration in the run demo playback loop script, there was a minor logic bug restricting the simulated hand sounds during demo playback. Inside the logic loop, the synthesizer triggers were checking for global sound on and global audio started, but were because getInstrument queries the active DOM state, looking for the checked radio input of left instrument and right instrument, but the demo state strictly depends on the separate, mock sandbox configurations inside. A simulated blue wrist node floats on the left side of the canvas. It has active green finger coordinates, representing the thumb and index finger, that slide inward and outward to represent human pinch interactions. Acoustics periodically maps the coordinate values to trigger low register synthesizer tones, e.g., D3. A simulated yellow wrist node floats on the right side of the canvas. Draws a complete facial mapping structure centered in the upper middle canvas. Renders a glowing lip mesh that dynamically scales open and closed. When wide open, the mouth's inner area glows with solid green transparency.
It's weird. Don't think we can. we'll do a demo song with it. We will change the gesture groove. We'll change the thumbnail to indicate that it was actually updated. Gesture groove thumbnail. Get rid of the old one. And we will pop it. We'll add the HTML entry like this to the bottom of our landing page. A hearing and speech, okay. It's more like music. Do we have a music? Probably should combine. Well, let's do music. I think it's more music than hearing than speech. Yeah, we have 9 music generators. And the gesture groove is to be removed from the top. Okay, shall we deploy real quick? We spent quite a bit of time on this one. Okay, so that's gone. Right, and we have the new thumbnail. It won't work. Oops. Currently will only work on Chrome. open Chrome. Wait, this is the old version, I can tell. Okay, this is the new one. It's actually working. Is it much better? Yeah, it's not doing the false detection. False detection was worse when the video footage is the quality of the video footage is reduced. The video footage. Yeah, now it can barely detect stuff. We'll test it one last time. This was a false mouth modulation. It was a false mouth modulation. Okay, we might leave it as is at the moment. Move on to something else. Yeah, everything we do is available on BioniChaos.com. Go check it out. Yeah, that's the one at the bottom. Yeah, we updated our eye tracking. We'll do a whole session on that. Just finished the gesture. Okay, so we actually made a few changes. If you can look at the page again. What did we do from memory? Yeah, we fixed the radio buttons, the tick buttons. So now we have the demo mode as a button now instead of automated start. We haven't changed the functionality for the left and right hand, and the mouth modulation, that's remained the same. We did update the text at the bottom of the page, so you should be able to look it up yourself. I don't know if we need to attach the code. Do we need to attach the code? I don't think this model will be able to handle the code. I don't know if I will paste the code. Oh yeah, there's false detections of hands on my hand, but that could be just because my video is a bit blurred out. Oh, I shouldn't have done that. I should not have done that. Okay, so it's actually, I was able to paste the code. I don't know why it was struggling so much. Hopefully this model should not start generating new code. Yeah, just generate text. So let's listen to that real quick.
Here is the updated, continuous, standalone script summary tailored specifically for streaming live to the BioniChaos audience. The boundaries of live browser-based music generation have been pushed even further with the latest updates to Gesture Groove on BioniChaos. If you remember the previous setup, the interface relied on an automated countdown sequence that would trigger a demonstration mode when the page went idle, which sometimes clashed with active camera interactions. Listening to performer feedback, that automated loop has been entirely removed and replaced with a clean, manual, demo playback button toggle right in the side options panel. Now, you have absolute control over when the automated coordinate simulation kicks in, allowing you to seamlessly experiment with the layout or test your speakers without the system making assumptions about your presence. The core gestural instrument architecture remains completely unchanged, meaning you can still dynamically map raw physical tracking directly to independent synthesizer engines for your left hand, right hand, and mouth modulations to sculpt complex audio topologies in real time. Beyond updating the informational layout and documentation blocks at the bottom of the page, this version directly addresses the frustrating issue where the system's spatial tracking would consistently mistake an ear or cheek for a hand, resulting in accidental frequency triggers. To resolve this false detection loop, a built-in face overlap ignoration filter has been integrated into the pipeline. The system now continuously calculates a precise bounding box around your face mesh landmarks in real time, and any hand markers entering or overlapping this specific zone are automatically filtered out and discarded. This ensures that only true hand gestures manipulate your linear pitches, gain values, and timing envelopes, providing a reliable, error-free physical performance loop. Did you know that all the tools developed live on our channel are completely open source and freely available to experiment with on link to BioniChaos.com? There is always a real human in the loop tracking your suggestions, so click over to the site, test out the new manual controls, and drop a comment on the stream or the page to let us know how the updated tracking handles your performance style.
Okay, so supposedly, yeah, it's so much better now. It's gonna revolutionize the world. Yeah, we'll keep testing it. If you are testing it, do provide your feedback. How does it work for you? Or if you faced any issues, everything we do is on BioniChaos.com. This one is all the way at the bottom of the page, but you also have this search tool. So we're doing the feature tools. Yeah, we'll go over it another time. Biology. It's meant to be more like physics, but this biophysics. We have cardiology, so pacemaker, PPG, simulations, detecting your. Wait, yeah, we had a new one. Detecting your heart rate using a web camera. Wait a sec. Pretty sure we had another one. It is demo Eulerian. It's the third one. Right, so it messed up. Meant to be cardiology. Can select that. Cardiology, made a mistake. Yeah, the feed data is also made a mistake. It probably should be data. Yeah, we have data science. Yeah, we have 51 tools in data science. Then we have vision, another vision, a game, and the neural network should be data science as well. Should be data science. There's 2 neural network simulators. Biomedical data. Yeah, this one I wanted to do a review on. I have a CRISPR simulation that meant to be biology. That's correct. Cardio. I wanted to do this. I don't know how to pronounce it. Lissajous curves. Lissajous curves. So it's in data science. Yeah, this one here. This one here. doesn't fit the screen really well. Not sure why. The canvas should fit perfectly, but never mind. Right, so the interesting thing about it, oops, yeah, we'll do a new chat. Yes, it's nice and quick description.
Have you ever stared at a complex dataset, like the firing patterns of a human brain or the rhythm of a beating heart, and wondered how we can possibly make sense of all that chaotic noise? It turns out that the answer might lie in the elegant geometry of Lissajous curves. Over at BioCurveViz, a fascinating tool hosted on link to BioniChaos.com, we are looking at how these mathematical curves can transform complex, oscillating biological signals into intuitive visual patterns. By mapping two different periodic components, say, an EEG stream from the left hemisphere of the brain against one from the right, onto an X and Y axis, the tool creates dynamic loops that instantly reveal frequency ratios and phase shifts. If the brain waves are perfectly synchronized, you might see a simple, elegant circle or line, but what happens when something goes off balance? How much easier would it be for a clinician to spot neurological abnormalities, or even predict an impending epileptic seizure, simply by watching a real-time shape distort on a screen? This tool bridges the gap between raw, overwhelming biomedical data and immediate visual insight, making it an incredible resource for cognitive studies and real-time surgical monitoring alike. Did you know that all the tools we develop live are freely available on link to BioniChaos.com? We highly encourage you to head over to the site, play with the interactive sliders to see how shifting a signal's phase completely rewrites its geometry, and leave a comment with your thoughts on how this could change data analysis. If you dive in and find yourself scratching your head, don't worry. There is a human in the loop if you have any questions about BioniChaos.
Okay, so we specifically wanted to explain this kinda. Okay, can you look at the image attached and explain exactly what's happening, what is happening? Mention the fact and explain that the frequency of the ECG waveform and the frequency of the pure sine is the same, being 5 Hertz. I'll give you another. There will be 2 images just in case. We want you to specifically focus on the third image, which is the actual Lissajous curve for this specific simulation. And while you edit, we want this specific setting. We want us also like a standalone paragraph to send to the developer of this application. We want this specific setting to be the default when we load the page. And also somehow we want to improve the user interface to get rid of the vertical scroll bars, if that's possible. So we want you to write a standalone prompt text only to the developer of this simulation. Stop it first. Let's see what it can do.
Understanding the simulation, one-to-one frequency vector plotting. The visualization demonstrates an advanced configuration of the BioCurve Viz tool where a real-time simulation vector plotter maps two signals against one another to generate a specialized phase space loop. In this specific setup, channel A, the x-axis, is configured as a pure sine wave with a frequency of 5.0 Hz and an amplitude of 1.50. Meanwhile, channel B, the y-axis, is set to an ECG loop waveform also running at a matching frequency, B, of 5.0 Hz, an amplitude of 1.00, and a phase shift, delta, of 0.50. Because both the pure sine wave and the complex biomedical ECG waveform share the exact same fundamental frequency of 5.0 Hz, they operate in a perfect one-to-one frequency ratio. Instead of creating a traditional scrolling time domain display, the left plot projects these inputs onto an XY plane. The resulting cyan curve is a unique vector profile where the horizontal deflection corresponds strictly to the smooth oscillation of the sine wave, while the vertical deflection captures the signature PQRST components of the cardiac cycle. The moving orange dot traces this exact trajectory in real time, transforming standard linear EKG peaks into an intuitive, recurring geometric loop that makes phase variations and morphological anomalies instantly recognizable. Feedback and feature request for the developer. Hi there. I am loving the BioCurve Viz application, especially how effectively it translates complex biomedical waveforms into distinct vector loops. I have a couple of suggestions to optimize the initial user experience and streamline the layout. First, could we configure the application so that the specific settings shown in these screenshots load as the default state? Having channel A default to a pure sine wave, frequency 5.0 Hz, amplitude 1.50, and channel B to the ECG loop waveform, frequency 5.0 Hz, amplitude 1.00, phase shift 0.50, sweep velocity 1.0, provides an instantly engaging, highly illustrative one-to-one frequency demonstration right out of the gate. Second, it would greatly improve the user interface if we could eliminate the inner vertical scroll bars on the left, parameters, panel, and the right, clinical presets, database. Adjusting the container styling to user responsive height, minor padding tweaks, or implementing overflow, hidden on the parent containers while ensuring the content scaled dynamically within the viewport would make the entire dashboard look incredibly sleek, unified, and truly professional. Thanks for your hard work on this tool.
Okay, that's nice. Can we rewrite the feedback, the prompt for the developer? So it meant to be more professional. It's a developer who's actually working for us. So yeah, we want to do this thing. So the default should be as described. But then another thing is, yes, somehow improving the user interface to get rid of the vertical scroll bars. We don't want to introduce horizontal scroll bars as well. And also a third thing is that in demo mode, we should show for, say, certain period of time, limited period of time, they're in sync, so two frequencies should be the same. So we have channel A as pure sine wave and channel B ECG loop waveform. To begin with, we have them both at 5 Hz, but then we show an example of them being out of sync, changing the frequency of the pure sine wave to say 5.1 and running that for a while to show the in sync, out of sync situations. Also, a fourth change that we want to describe to the developer is we want to get rid of the automated start of the demo loop. We want to have a button instead. So maybe you can expand on that and describe it properly so it's a standalone prompt for the developer.
Here is a professional, structured specification document you can hand directly to your developer. It outlines the interface refinements, the new demo feature, and the specific default states clearly. We want to implement a few updates to the BioCurve Viz application to refine the user interface, adjust the default landing state, and add a structured, manual demo mode. Please see the detailed specifications below. Upon initial page load, the application must initialize with the following configuration. Channel A, x-axis, asterisk waveform, pure sine wave. Channel B, y-axis, asterisk waveform, ECG loop waveform. The current layout introduces vertical scroll bars on the side control panels, parameters, and clinical presets, which impacts the visual flow. Goal: completely eliminate the inner vertical scroll bars from these panels. Constraint: ensure that fixing the vertical overflow does not introduce horizontal scroll bars. Implementation: please refactor the CSS layout using a responsive approach, e.g., Flexbox, CSS Grid, or subtle adjustments to padding, margins, and font scaling, so that all controls fit cleanly within the viewport across standard desktop resolutions. Demo mode refactoring, manual trigger and out-of-sync sequence. We want to modify how the presentation, demo sequence behaves. Disable auto start, remove the automated script that kicks off the demo loop immediately on page load. Manual trigger button, add a dedicated, prominently styled, run demo sequence button within the UI. The sequential logic, clicking this button should trigger a specific two-part simulation loop. Phase 1, in sync, run the default parameters described above, both channels locked at 5.0 Hz, for a specified duration, e.g., 10 to 15 seconds, to demonstrate a perfectly synchronized, stable Lissajous ECG vector profile. Phase 2, out of sync, automatically shift the frequency of channel A, the pure sine wave, from 5.0 Hz to 5.1 Hz while leaving channel B at 5.0 Hz. Let this run for a set duration to explicitly demonstrate the dynamic drifting and phase distortion that occurs when the signals are out of sync. Please let me know if you need any clarification on these requirements or if you foresee any constraints with the CSS refactoring.
Okay, so they're running this locally. We have Gemini 3.5 Flash working on the code. Hopefully in demo mode it will have some sort of, we didn't ask explicitly for it, but hopefully it will have a thingy there explaining what the demo mode is currently showing. Supposedly out of those clinical presets. They're pretty good.
Initiating the analysis. I'm diving into this HTML file. My initial focus is the interactive data visualization aspect, especially how the Canvas 2D and Web Audio API are integrated. The dynamic states and responsiveness are also high on my list. Refining the initial specs. I just finished a thorough review of the technical specifications. I'm now zeroing in on the specific modifications needed, primarily the default landing configuration and the UI layout adjustments to eliminate scroll bars. The requested changes to the channel parameters are quite specific, so I'm paying close attention to those numerical values. Adjusting for UI enhancements. I'm now completely focused on the UI elements. Specifically, I have to ensure the layout fits all controls within standard desktop viewports, removing any vertical scroll bars. Adjusting padding and flexible font scaling are top priority. Also, I'm thinking through how to refactor the demo mode to include a Run Demo Sequence button for a two-phase simulation. Phase 1 will demonstrate synchronized parameters, and Phase 2, desynchronized parameters. Implementing parameter interactions. I'm now integrating the event listeners for user interactions. I need to make sure the app updates the canvas and audio when parameters change, either when clicked or through direct manipulation. Specifically, I have to ensure the canvas and audio update responsively to all of the UI elements. I'm focusing on the click or other actions of the parameter interface, as well as the changes described in the code block provided in the analysis. Optimizing vertical layout. I'm now zeroing in on removing those pesky vertical scroll bars. I'm actively reducing vertical margins and padding across various elements, such as control group and panel body, to make the interface more compact. The goal is to set overflow Y, hidden on panel elements, and ensure the layout comfortably fits within a standard viewport height, like 600px or more. My current focus is on optimizing the panel content by arranging channel A and B controls horizontally or stacking them more efficiently within the left panel to achieve a clean, scrollbar-free display. Finalizing vertical adjustments. I'm now implementing the CSS tweaks to eliminate those scroll bars for good. I'm focusing on the panel body to set overflow, hidden, and using flex grow to allow it to expand to fill available space. I'm reducing vertical margins on control group and padding in panel body to create a more compact layout, as well as making slider wraps tighter. Also, I'm adjusting the height of the range inputs to fit everything within the 75v8 minimum height requested. Implementing UI compression. I'm now zeroing in on UI element adjustments for tighter layout. I'm focusing on CSS updates to reduce component heights and margins. Specifically, I'm adjusting heights for select and button elements, and reducing margins for horizontal rule elements, hour. The objective is to prevent overflow while keeping the UI accessible. Adding demo sequence button. I'm now implementing the Run Demo Sequence button, placing it in half-panel dash controls. I'll style it as a primary button using a consistent theme and color, though I'm still considering a suitable color choice. I'm focusing on coding the demo sequence behavior, including a DemosQ active flag, a DemosAQ phase indicator, and a timer to manage the different phases. I will visually enter demo mode. Defining demo sequence logic. I'm now creating the logic for demo mode. I've set initial values for phase 1. Channel A is sine at 5.0 Hz, channel B.
Okay, so it's thinking Gemini 3.5 Flash, but then not sure if it implemented the demo mode. So yeah, it changed the default. It was able to improve the user interface, so there's no scrolling scroll bars. We had vertical scroll bars before, so they're gone. We have these clinical presets. I'm not sure if they're making much sense at all. Sweep velocity doesn't work. No, phase shift does work. Yeah, I'm not sure the clinical presets are making much sense or not. But I don't think it implemented the demo mode. So let's... Okay, so it did this correctly.
Default landing state. Channel A, x-axis, initializes as a pure sine wave at 5.0. 5.0. H said with an amplitude of 1.50. 1.50. Dot. Channel B, y-axis, initializes as an ECG loop wave format. 5.0. 5.0. H said with an amplitude of 1.00. 1.00. Dot. Phase shift. Delta. delta is set to 0.50, 0.50, and sweep velocity is set to 1.0, 1.0, dot.
Okay, the sweep velocity does actually work. Wait, let's make it a bit slower so we can actually see the ECG waveform. Let's go 1.5. Okay, the phase shift. Okay, so it's hard to select 0. Okay, so that's actually nice. So we have phase shift, that makes sense. Now we were asking in demo mode to do this out of phase. So it's continuously changing. So it's not a constant phase shift like that setting there, I assume. Yeah, I'll need more explanation on that one. Okay, so it fixed the UI layout. Okay, with the demo mode.
Removed all automated page load and activity loops. Integrated a prominent, yellow accented, run demo sequence trigger in the parameter panel.
In the parameter panel. Okay, I can't see it. Let's reload the page. Where exactly is the run demo sequence trigger button? I don't seem to see it. Ah. Well, right, I'm able to see it when I zoom out. However, we would like everything to be in a single page, so I don't have to zoom in, zoom out to find anything. Ideally, everything will be visible in a single page, the whole canvas. It's a pretty straightforward canvas, I think, so we should be able to do it. Okay, it's good that the demo mode has this overlay actually explaining what's happening. But can we potentially add more phases to it? Yeah, we want like 3 and 4 or 5, whatever you think is suitable to showcase what the web application does. Perhaps we can go through the clinical presets one at a time. So like cycle through them in the demo mode. Currently I don't quite understand. The clinical presets don't make much sense. So maybe we can update the code if you're confident. If you are not sure how to update the code, just include the description, a text below the canvas at the bottom of the page. And yes, we need to expand that text and update it anyhow. Okay, let us run this prompt. Let's see what it says. Yeah, the clinical presets don't make much sense. Yeah, because it's essentially showing just well, it's kind of face lock when it's a single line, is it? So if you face lock it, if it's close to 0, then just see a single line. You can make that sweep faster. Yeah, we can have a demo which does the square thing that's happening when you keep changing the phase shift up and down. So I don't know if it makes sense. It does make sense, but it makes a good visualization.
Here is the refined, single-file HTML implementation. To address the display issue shown in your screenshots, the layout CSS have been structured so that the entire workspace, including controls, visualizer canvas, and preset options, fits cleanly within standard desktop viewports without requiring manual zooming or creating scroll bars. Key improvements made. Viewport optimization. Replace vertical spacing metrics with compact paddings and margins. Lock the dashboard container, .app viewport, to a maximum height of 600px to fit the entire UI above the fold on standard desktop resolutions. Tighten card layouts and form elements to guarantee that buttons like Run Demo are completely visible on standard displays. 5-phase advanced demo sequence. Cycles through 5 distinct physiological and mathematical states. Displays clear, structured telemetry details on an overlay card, cycling automatically every 10 seconds. Features a new custom clinical signal generator for absence seizure spike wave discharges. Enhanced clinical accuracy. Refined the parametric equation model to render more realistic spatial vector traces, such as correct cardiac electrical rotation vectors. Expanded the analytical documentation below the canvas to clearly explain the mathematical and biomedical relationships of the simulated profiles.
Yeah, it's hallucinating on me now a bit. Okay, yes, so okay, it's phase 5. Uh, okay, a couple of things. Can we move the local session registry somehow to the bottom of the canvas. Maybe combine it with the simulation vector plotter, or yeah, so essentially combine the local session registry with the simulation vector plotter, and make it smaller so it actually fits at the bottom of the canvas. Now the clinical presets, yeah, those are good, but currently the demo is showing 5 or 6 presets. Okay, so in the demo mode, can we just like essentially have all the presets from the demo mode and the clinical presets? Can we combine them to have them in one list? And when in demo mode, we just like highlight which one is currently being displayed, and have the short description of what's going on. But yeah, we essentially want that default one that is showing when we load the page to be a clinical preset as well, and kept in the demo mode. And the other one where we have the pure sine wave at 5.1 frequency as well as another clinical preset. Have a short description. In demo mode, we just like cycle through them. So we should have in theory 1, 2, 3, 4, 5, 6 of them. And we should have enough space on the right panel, so we don't require a vertical scroller. Not sure. Yeah, we did minimal thinking. How about a different model? We go for Gemini 3.1 Pro. Wait, thinking level. Yeah, I'll do medium thinking level. Should have probably compared between two models as well or something.
Can we move the local session registry somehow to the bottom of the canvas? Maybe combine it with the simulation vector plotter, or yes, essentially combine the local session registry with the simulation vector plotter and make it smaller so it actually fits at the bottom of the canvas. Now, the clinical presets. Yes, those are good. Yes, those are good, but currently the demo is showing 5 or 6 presets. In the demo mode, can we have all the presets from the demo mode and the clinical presets? Can we combine them to have them in one list? When in demo mode, we just highlight which one is currently being displayed and have a short description of what's going on. But yes, we essentially want that default one that is showing when we load the page to be a clinical preset as well and kept in the demo mode. And the other one when we have the pure sine wave at 5.1 frequency as well. Key refinements based on your feedback. Consolidated Registry and Canvas Legend, the local session registry, have been moved out of the right panel and integrated directly into the bottom right corner of the canvas overlay. The font and padding were minimized to keep the canvas clean and unobstructed. Unified 6-phase preset list. The clinical presets and demo phases have been combined into a single, unified vertical list on the right panel. It includes the default sine versus ECG configuration as the first item and the phase drift 5.1 Hz configuration as the final item. Scroll-free compact GUI, the spacing, typography, 0.75 rem headers, 0.65 rem descriptions, and padding of the preset cards have been heavily optimized so all 6 items fit perfectly on the right panel without triggering a vertical scroll bar. Synchronized demo mode. When you click Run Demo, the application automatically cycles through the 6 items in the list every 10 seconds. The currently active phase is visually highlighted in the list with a bright border, a subtle background glow, and a small, active indicator. Clean Demo Exit. The Run Demo button dynamically transforms into a red Stop Demo button while running. Interacting with any parameter or clicking another preset will instantly stop the demo sequence.
Okay, so this is... Okay, let's check when you load the page. Baseline, is that the baseline vector map? Then we have baseline vector. Yeah, I was expecting 1 and 6. So we have 6 clinical presets and demos. Okay, the first one is working okay. That's when the frequencies of both the sine wave and the ECG waveform are 5 Hz. Then you can have, and that's called baseline vector map default. Comparative view plotting a pure 5 Hz sine wave against the 5 Hz synthetic ECG loop, and you see the resulting Lessages curve. Then you have a harmonic frequency phase drift, non-integer harmonic ratio 5.1 versus 5.0, causing the vector pattern to continuously rotate and drift over time. That's really nice, thank you very much. Then we have a vector cardiogram, healthy ECG. So it's supposedly 2 leads, lead 1 versus lead 2. And there is no difference between them. Depicts synchronous 1 Hz depolarization coordinates of cardiac muscle. Right, so they are identical in that case. Have EEG occipital alpha wave sync, simultaneous symmetrical 10 Hz brain activity, representing alpha frequency locking across sensory regions. Are they out of phase a bit? Both amplitude. One is the higher amplitude. A phase shift. Yeah, so that's the result of a phase shift. So yeah, the thing about it, you can barely see it on the time domain, but you can clearly see the difference on the Lessages curve. You can do sweep velocity, just going faster and slower. Wait, that was EEG. Okay, and this one has spikes. So EEG with seizure discharges. Okay, but what's the... You would kind of expect the 2 channels, assuming this is 2 separate channels, to be different, to be slightly different. Yeah, so that could indicate potentially how the seizure is spreading through the brain and things like that. But yeah, let's toggle demo. Demo mode should just cycle through the 6 clinical presets. Thank you very much. Is it staying on a single one for long enough? Yeah, it should ideally clear the thing when moving to the next demo. Should we leave it as is? No, leave it as is. Yeah, these two, the first and the sixth, should really be together on the list. Okay, so this is really nice. It's working really well. We just need to improve and update and expand the text on the bottom of the page, but maybe do this after adding one or two more clinical presets. We want one where, for example, you have two ECG waveforms from two different channels, and there is actually a non-visible difference between them. So we essentially want to show that in the time domain, the difference between the ECG waveform on two channel is not discernible, that we cannot actually see it, but the Lesage's curve is actually showing the difference in a clear fashion. So we want one example like that for ECG and one example for EEG. So essentially two channels where you have some difference between them that is not clearly visible in the time domain, but clearly visible with the Lesage's curve. And also a minor change, we want the harmonic frequency phase drift to be coming straight after the first demo, the baseline vector map. So we want actually the sixth item to be second. We will add an image to it just in case. I'm not sure which model to use. Let's do 3.1 Pro. Yeah, thinking level medium. Just keep it the same as the previous prompt, because the previous prompt output did work really well. Oh, and the demo should be cycling through the presets. I think now it's potentially only doing one cycle.
Key adjustments. New clinical presets added. Subtle ECG conduction delay displays two ECG waveforms that look identical in the fast time domain sweep, with a tiny 0.15. 0.15. Rad delay instantly causes the Lissajous curve to balloon into a wide loop, revealing a hidden conduction delay. Hidden EEG asymmetry displays two complex, noisy EEG signals. The noise makes it impossible to see the phase lag in the time domain, but the spatial vector plot clearly draws an open, tilted ellipse rather than a synchronous diagonal line. Reordered sequence, harmonic frequency phase drift, has been moved to the number 2 spot immediately after the baseline map, as requested. Expanded and focused academic text, the informational articles at the bottom have been heavily revised to focus explicitly on why Lissajous curves are used, specifically detailing how they reveal hidden phase relationships, delays, and structural anomalies that the human eye cannot discern in standard time domain charts. UI compaction. I reduced the padding, margins, and font sizes of the preset cards slightly, and increased the application's maximum height slightly to 720px. This ensures all 8 presets fit cleanly in the right panel without requiring a scroll bar on standard desktop displays.
Okay, we'll probably, we'll go over these ones real quick. We'll probably add another one where we have a sinusoid in one channel, and the second channel will be a EEG of a certain waveform, of a certain frequency. But currently, just go through those quickly. Here we have a baseline vector map default view plotting 5 Hz sine wave against the 5 Hz ECG loop, so that's kind of useful. Then we have, well, it's especially useful when you compare it to the second clinical preset, which is harmonic frequency phase shift, where the only difference is that now you have the sine wave at a different frequency. So 5 Hz is 5.1, and you can see this, so frequency mismatch, 5.1 versus 5 Hz, causing the vector pattern to continuously rotate and drift. So you have this like constant rotation. So that's nice as a demo. Then you have a vector cardiogram, healthy ECG, lead 1 and B, perfectly synchronous cardiac depolarization coordinates. So you get two leads, 1 and 2, and have exactly the same waveform. Okay, and then you have a subtle ECG conduction delay. So there would be inflates the Lissajous loop drastically. Yeah, I'm trying to see what the difference in the settings. That doesn't work. I suspect there should be a good explanation to it. Okay, let's move to the next one. Okay, we have two EEG, symmetrical 10 Hz, representing alpha frequency, locking across sensory regions. You have a 0.15 phase shift, okay. And if that's 0, that line will be more like a line as opposed to an ellipse. Right, and then we have this hidden EEG phase asymmetry. So yeah, so in the time domain you don't see, they kind of look the same. There's some sort of phase shift. It's hard to actually see it. The noisy EEG signal obscure a massive 0.6, a 0.6 red phase shift lag, which is the special vector plot clearly exposes. Yes, so whatever is hard to discern from the time domain can be easily seen in the Lissajous curve. So that's kind of nice example. Frontal theta phase lag renders frontal displaying localized propagation latency. Okay, it's just a simple phase shift. And then we have that spike indicating a seizure. Okay, just two last things, and we are out of here. So with the last one, the spike seizure discharge, can we keep this one, but have another example where the spikes on different channels are out of sync, while the other brain activity is the same? So we want to see an example like that. Okay, and the other thing, we want to kind of understand the difference between clinical preset 3 and 4. Currently, well, the problem with it that is currently all the components of the ECG wave are still exactly the same. So that in this case, the phase shift doesn't do anything for whatever reason. So I'm not entirely sure if it's a problem in the code, or we could just add a text explanation describing what's happening in that case. So essentially, again, there's no discernible difference between clinical preset 3, the healthy ECG, and the clinical preset 4, which is that subtle ECG conduction delay. The phase shift in that case doesn't seem to make any difference. Should we instead change the frequency slightly for one of the channels instead? I'll add these two images to it. Yeah, in the two images, the second image shows that the subtle ECG conduction delay currently is still generating just a straight line, same as for healthy ECG. And the first image is the result of actually changing the frequency for the second channel, for channel B. Okay, so we have Gemini 3.1 Pro regenerating the code. This is like the fifth, sixth or something prompt that we are doing. Should be out of here. Yeah, there's some interesting things every time it's making a change. There's some interesting stuff that comes out of it. So essentially we have this biomedical data visualization. We have an example of where you have two channels. You can select sine wave, ECG, EEG, and EEG with a seizure discharge. EEG with a seizure discharge. And now, and the interesting thing about it is that we're showing this third curve, which is called Lysage's. Lysage's? I don't know how to pronounce it. Lysage's curve. That one is an interesting one because essentially what it does is shows in a better way some differences between two time series channels. So for example, if you have two channels in out of sync or something, it's hard to discern that, to see that on your time series chart. But the Lysage's curve will show you that something is going on. So that's why we are spending so much time on it. Okay, and we made some changes. Okay, but we have a baseline works, harmonic frequency phase shift drift works. And then we have this, a healthy ECG should just show a steady one line. Yep, that works. Conduction delay. Okay, so we're actually changing the phase now. The board have decided, no, actually keep the frequency the same. Keep the frequency the same. Interesting. Okay, the previous one had a phase shift of 0, and this one, the only difference is that it has a phase shift of 15 radii. Radii? Let's actually find the explanation. It was able to fix the code, I'm just not sure. Let's read that quickly. You completely caught a bug in the code. Well, I didn't. You did. Well, thank you.
Fix the underlying.
Okay, there was a bug in one of the math equations. Let's listen to it quick.
You completely caught a bug in the code. The reason the subtle ECG conduction delay, preset 4, wasn't doing anything is because the mathematical function generating the ECG wave was accidentally ignoring the phase, delta, parameter. I have fixed the underlying math equation.
Okay, now it does work though. I can tell it wasn't working before, now it does work, but did I catch the bug? Well, maybe. Did you fix the code? Yes, Gemini 3.1 Pro did. So, thank you very much.
Now, preset 4 works exactly as intended. The 0.15 radians delay is so small you can't easily see it in the right-hand time domain panel, but the Lissajous curve on the left dramatically balloons into an open 3D-looking loop, perfectly mimicking a real clinical bundle branch block vector.
Right, so that's a good explanation. That's very nice. So you can see in healthy ECG the two channels. So we displaying time series data from two channels, and it's showing exactly the same thing. So the Lissajous curve is a straight line, which is nice. Now, with the subtle ECG conduction delay, we have a phase shift of, instead of 0, we have it now at 0.15 radii. And now we see this weird butterfly shape, indicating to us that something is going on. So if it's not a straight line, you should know that something is up between the two curves. So when you just look at it, they look identical, but they're actually out of phase. Yeah, so how good is the Lissajous curve? Then we have occipital alpha waves. They're also out of phase. So you have this elliptic shape, a hidden phase asymmetry with noisy EEG. So you get that interesting shape. Again, something that will be harder to see from the time series. Frontal theta phase lag. Yes, it will be another elliptical shape because of the phase shift. Okay, EEG spike seizure. So we have a standard one. So we have a straight line. With that, the red dot is spiking, jumping as well when you in sync with the spike, the seizure spike. And then we added another clinical preset. We have this asynchronous seizure spike. And again, from the time series, we cannot see the difference, but if you look at the Lissajous curve, you can see this weird shape. So it should tell us that something is up, something is wrong. So they're not identical, there's some sort of phase shift. And yes, now we should have a demo mode that will cycle through this 1, 2, 3, 4, 5, 6, 7, 8, 9 presets. We can probably squeeze another one in there of your choice. If you have a suggestion, do let me know. Otherwise, yeah, I'm pretty happy with Gemini 3.1 Pro. Thank you very much. I'm just wondering, when it's cycling through the demo, is it staying for long enough in each preset? Okay, it kind of is. It's clearing the whole page. So it's very nice. Check the thumbnail. The thumbnail for it is pretty good. We will redeploy the page so it's available for you to test. Did you know that you are doing all the testing for us? How cool is that? Yep, that's the updated version. Yeah, we won't worry about the zoom size at the moment. It should be in data science. Yes, it is. Yeah, it's available for you to play, so go check it out. And we will do a review with another model. Okay, we actually updated the web application. Can you review the text? I'll share the text on the page with you just in case you can't access it. Sometimes you're having trouble accessing it, but essentially we want another standalone review of this web app, what it does, how good it is for biomedical engineers and medical students, and how useful is Lisage's curve in biomedical data analysis. Oh, come on, it's not that much text. Yep. Hopefully it will be standalone without bullet points. Does have bullet points, but we'll still use it.
Web Application Review, BioCurve Viz, BioniChaos, Review a Category, Biomedical Signal Processing and Clinical Telemetry Education. Target Audience, Biomedical Engineers, BMEs, Clinical Neurophysiologists, and Medical Students. Overview of the application. BioCurve Viz by BioniChaos is an interactive, browser-based simulation platform designed to demonstrate the transition from traditional time-domain signal tracking to multi-channel phase space analysis. By plotting complex biological waveforms against one another using Lissajous vector mapping, the tool acts as a virtual vector cardiogram, VCG, and quantitative EEG, KEEG, phase space monitor. The web application features a dual display interface, a simulation vector plotter on the left showcasing the geometric XY coordinate phase space, and a fast time domain sweep on the right acting as a classic dual-channel oscilloscope. It supports custom parameter adjustments, waveforms, frequencies, amplitudes, phase shifts, and real-time stereophonic sonification, alongside an extensive database of clinical presets. The clinical and engineering problem: why Lissajous curves matter. In conventional medical diagnostics, physiological signals like the electrocardiogram, ECG, and electroencephalogram, EEG, are monitored as a function of time, F, T, versus T. While this standard strip chart or scrolling display is effective for identifying basic rate and rhythm abnormalities, It fails when evaluating inter-channel relationships, propagation delays, and network synchronicity. Noisy, high-amplitude biological artifacts frequently mask microsecond latency differences between distinct sensors. If a medical student or engineer tries to visually compare two scrolling, noisy waveforms on an oscilloscope, detecting a minor phase lag is nearly impossible. Lissajous curves solve this by omitting the time axis entirely, plotting the voltage of channel A, x-axis, directly against channel B, y-axis. This mathematical approach transforms temporal data into spatial geometry. Complex calculus and signal processing equations are converted into immediate visual forms. Perfect synchronization, 1-to-1 ratio, 0 circ phase, collapses into a single, clean diagonal vector. Phase shift, propagation delay, the vector instantly inflates into an ellipse or loop. Frequency mismatches, harmonic drift, the geometry rotates dynamically, offering a clear visual representation of desynchronization. Core strengths for medical students. For medical students, abstract concepts like cardiac axis deviation, bundle branch blocks, and hemispheric EEG alpha wave synchrony are notoriously difficult to conceptualize from static textbooks. BioCurve Viz bridges this pedagogical gap through interactive experimentation, visualizing hidden anomalies. The subtle ECG conduction delay preset is a premier educational module. In the time domain, the two leads appear perfectly synchronous to the naked eye. However, the Lissajous plot immediately balloons into an open loop, visually demonstrating a 0.15 text rad micro delay, the classic precursor to early bundle branch blocks or localized myocardial conduction damage. Decoding neurological seizure dynamics. The asynchronous seizure spikes preset provides an excellent lesson in neurophysiology. Students can observe how the background slow waves stay locked on a synchronized diagonal line while the pathognomonic spikes branch outward into sudden loops. This clearly isolates normal synchronized brain activity from localized paroxysmal seizure foci. Core strengths for biomedical engineers. For BMEs and neural engineers, the platform serves as an intuitive sandbox for digital signal processing, DSP, principles and instrumentation design. Phase space prototyping. Engineers can witness how raw mathematical equations dictate vector trajectories. Tweaking the frequency, A, B, and phase shift, delta, inputs provides an immediate grasp of coordinate mapping, vector space constraints, and phase velocity drift. Multi-sensory data representation, sonification. The inclusion of an audio node mapping X and Y frequencies into stereophonic acoustic channels is highly relevant to modern BME research. It provides a foundational look at sonification, using auditory telemetry alongside visual displays to reduce cognitive overload for clinicians in high-stress environments like the ICU or OR. Assessment of recent UI/UX updates. Comparing this version to its developmental prototype shows significant, professional-grade improvements. Elimination of UI clutter. The inner vertical scroll bars inside the parameters and clinical presets side panels have been cleanly engineered away, resolving previous viewport limitations without creating hazardous horizontal overflows. Refactored demo sequence. The implementation of a manual Run Demo button, replacing the intrusive Auto Start sequence, gives users total control over their learning pace. The 9-phase sequence systematically transitions from a perfectly in-sync baseline to precise, 1-to-1 harmonic drifts. 5.1, text, HZ. VS 5.0, text, HZ. Demonstrating signal deviation over time. Optimized layout flow. The dashboard looks balanced and responsive. The high-contrast neon graphics against the dark simulation grid mirror modern clinical diagnostic hardware, elevating the professional aesthetic. Final verdict. BioCurve Viz is an outstanding educational and analytical tool that succeeds in making complex biophysical wave interactions tangible. By lifting the curtain on phase space analysis, it equips medical students with spatial diagnostic intuition and provides biomedical engineers with an interactive canvas for signal processing theory. It is a highly recommended resource for clinical telemetry coursework, DSP laboratories, and neuroengineering demonstrations.
How the current sonification works. Right now, the sonification translates the physical movement of the visualizer into a stereophonic soundscape in a direct, dual-channel mapping. Left ear, channel A, x-axis, plays a continuous pure sine wave. Its pitch, frequency, is tied directly to the speed of the horizontal signal. A. Closing parenthesis dot. Right ear, channel B, y-axis, plays a separate continuous pure sine wave. Its pitch is tied directly to the speed of the vertical signal. B. Closing. Because the system is using standard pure sine waves, the simplest, smoothest sound wave in physics, the audio sounds like a flat, sterile laboratory test tone. It lacks texture, character, and organic movement. Additionally, because the tones play continuously at a constant volume, the sound does not breathe, pulse, or mimic the dynamic rhythm of the biological systems you are looking at on the screen. To make the audio far more immersive, organic, and clinically intuitive, the sonification can be redesigned around three main principles: timbre, texture, rhythmic pulsing, amplitude envelopes, and phase-driven spatial movement. One. From flat tones to warm, organic textures, timbre. Instead of sterile sine waves, we can use complex waveforms, like triangle or warm saw waves, passed through low-pass filters. The effect: this shifts the sound from a cold, computer beep to a warm, humming, cello-like tone. Adding grit for noise. For presets like the noisy EEG brainwaves, we can introduce a subtle, low-volume, pink noise, hum. This would make the sound feel like the fuzzy, complex neural activity you are seeing in the time domain plot. 2. Synchronizing volume to the heartbeat, rhythmic pulsing. Currently, the ECG presets make a continuous sound. In a real clinical environment, we expect rhythmic, pulsing sounds. The improvement: we can modulate the volume, amplitude, of the tones to match the actual waveforms. The effect: instead of a constant drone, the sound would swell and chirp exactly when their ECG's QRS spike occurs, and quiet down during the flat rest periods. For the EEG seizure preset, you would hear a rapid, rhythmic, thumping pulse that mimics the hypersynchronous cellular firing of a brain seizure, rather than a continuous flat buzz. 3. Mapping phase to spatial audio, directional panning. Right now, the left channel is permanently locked to the left ear, and the right channel to the right ear. The improvement: we can use the actual opening parenthesis x, comma, y, closing parenthesis x, y, coordinate point on the visualizer to drive where the sound is positioned in the stereo field in real time. The effect: as the glowing dot moves in a circle or loop on the screen, the sound would physically spin around your head in stereo. If the signals are perfectly in sync, drawing a diagonal line, the sound would remain locked in the center of your head. If there is a subtle phase delay, opening the loop, you would instantly hear the sound start to orbit or widen in stereo space. The wider the loop on the screen, the wider and more circular the sound's motion would feel around your ears. 4. Harmonic concordance, chord structures. To make the pitch changes more pleasing, the raw signal frequencies can be mapped to musical intervals, like a perfect fifth or major thirds, rather than raw mathematical values. The effect: synchronized signals would ring out as a harmonious, pleasing chord. As the signals drift out of harmony, such as in the harmonic frequency phase drift preset, the chord would slowly detune, creating a dramatic, tense auditory rub dissonance that clearly flags the loss of coordination. I would be glad to implement this sonification upgrade. The code has been updated to transform the flat test tones into an organic, responsive auditory environment without altering any of the underlying mathematical plotting, layout structures, or your 9 clinical presets. Summary of sonification updates. Warmer timbre: swapped out the harsh sine oscillators for triangle waves and routed them through a customized low-pass filter to deliver a softer, more analog sound. Rhythmic volume modulation: the volume, gain, of channel A and channel B is now driven in real time by the amplitude of their respective waveforms. The sound now organically pulses and beats with the ECG complexes and seizure spikes instead of droning continuously. Dynamic stereo panning: the audio pans left to right and top to bottom based on the actual opening parenthesis x, comma, y, closing parenthesis x, y, coordinate of the visualizer's tracing dot. When the signals are in sync, the sound sits comfortably in the center. As phase drift or delays open up the Lissajous loop, the sound physically orbits around your head. Organic noise jitter: when running complex EEG or seizure presets, a subtle, randomized frequency jitter is introduced to simulate natural neural noise, giving the channels a textured, biological feel.
Yeah, let's actually see. Sorry, so we're trying to improve the sonification on this thing. And supposedly we added warmer timbre, rhythmic volume modulation, dynamic stereo panning, organic noise jitter. Don't know why we need the jitter, but okay. Okay, we had just under 1,000 lines of code, 918. The new code is 985. And we have to go back, run it locally, because we already deployed. Let's actually have it in the same. I have it in the same browser, if you may. I'll test the audio for it. Okay, so you have the left and right ears. Something is happening there. Let's hear the. So this one's just two waveforms oscillating. The other one does. Okay, that's the healthy ECG when they are totally in sync, the two channels. Yeah, this one does just this one oscillation, including in the sound. And the other one, so this is healthy ECG, and the other one is conduction delay. I don't know if I can hear the difference, but yeah, if you look at it, which is like a neurofeedback thingy, then you can, it kind of makes sense. EEG occipital alpha wave, just go in a circle. That's when you can hear that this one's just elliptic. I don't know if you are biasing yourself by looking at it as well. But when you're doing the phase symmetry, yeah, you can hear some other complications in the sound. And that's the spikes. So it's in sync spikes. Seizure, epileptic seizure spiking in EEG, in sync on both channels. And this one asynchronous. Yeah, the in sync does kind of one swoosh sound, and asynchronous does two or three of them. So it kind of does make sense. I'll have the demo running.
Here is the updated single-file HTML. The informational grid at the bottom has been fully revised and expanded to detail the science and physics of the new advanced sonification engine. Key documentation updates included: the physics of phase to panning mapping explains how. Opening parenthesis. X, comma, Y, closing parenthesis. X, Y. Coordinates are converted into real-time stereophonic panning, creating a physical, orbiting, acoustic rotation that corresponds to phase shifts. Biomedical amplitude modulation explains how the volume envelope tracks signal peaks, transforming a flat drone into rhythmic, organic pulses, such as cardiac beats and seizure spike bursts. Binaural auditory diagnostics discusses how clinicians and researchers can use dual sensory feedback, combining visual phase loops with acoustic harmony and spatial movement, to detect micro-anomalies that are typically missed in standard time domain scrolling.
Okay, so we improved the text at the bottom of the page. We redeployed. You can test it out yourself. There's the sonification, the demo mode, the cycling through this 9 clinical presets. And let me know if you can think of any other changes or improvements to this thing. I think this tool is going to the top of the landing page. What do you think? Does it deserve a top spot, top place, or not? I think it does. I think it does. Well, it also will indicate to us that we covered it in the videos, in the streams. So we have a video overview on it. Okay, so we still have 28 things to improve or fix on the site. This one went to the top of the landing page. Thank you, Gemini. Yeah, we have it first spot. Yeah, I really like it. It's a really nice visualization tool. Go check it out. Provide your feedback how we could improve it, because I cannot think of any further improvements. It's pretty, looks like pretty perfect to me. So we could actually use it as a template for our tool. That's really good the way it's designed. That's someone asking if the chatbots, if the robots we're using are ours or not. So they are currently not ours. We do have our own chatbot. do we fix this virtual lab? We split it into epilepsy study and audiometry study as separate tools, probably. Actually, not sure if the demo mode is working at all or not. Well, the demo mode is working. It's the sonification. Yeah, the sonification is not doing much at the moment. Okay, so we're about to finish up. Yeah, we made this biomedical data in Lessages. I don't know how to pronounce it, Lessages curves visualizations. But yeah, it's really handy visualization to show you things that might not be visible in time domain. So it's not frequency domain or anything, it's this 2D drawing thingy, like a curve. So if it's a straight line and that red dot is going up and down, it means the two signals, channel A, channel B, are identical. If you see an elliptic thing, that means there's a phase shift. And if you see this like weird shapes, then there's something else going on. So it kind of helps you, and we have sonification to it as well. Sonification to it. Yeah, so we have Gemini. We have like Gemini developing all the code for us. And we making have this yeah, so everything we do is available on BioniChaos.com. Go check it out. We kinda at the moment we have the best tools up the top of the landing page. We now restructuring all the tools, and they will be going, they're currently being dumped at the bottom. But eventually, once we finish testing, you can help testing, by the way, then they will be going up the page, up the hierarchy list. So had this a blog on histopathology. We have these two images in it and a bunch of text. But essentially, and then we have this secret source, whatever prompt, essentially replacing an experienced developer, potentially turning this into interactive web application. So that's what we do. And we had some code. The blog was 90 lines of code, right? And the developer, which is essentially a prompt given to Gemini in this case, was working on it for some time, 10 minutes or so, and then it generated out of 100 lines of text description, it generated over 1,000 lines of code. And let's actually test it. We have to run it locally, and we'll have to run it locally. Okay, this is like a canvas. Canvas is good. It's like staining. It's microscopy, virtual histology analyzer, AI segmenter. Okay, we have a lens, we have a cell density. Okay, that actually you have to release that scroller for anything to change. Interactive tissue microanatomy simulator with real-time neural network detection masks. Oh, okay. I don't know why. Computer vision. Okay, we have this. Yes, it's a simulation of computer vision. Bounding boxes. Okay. Semantic masks. Okay. Start AI diagnosis with. It's nice. looks real. I don't know what the canvas. There's a description, some links. We're not gonna read any of it. We're not gonna do anything silly like reading anything, are we? That was a joke, by the way. Individual neurons. So the canvas is essentially the demo, a sample of histopathological slice image. Where is it finding? Model score threshold. Detected neurons. Okay. Fluorescent multi-channel dye. It's finding stuff in your histopathology sample. You still have the overview and everything. So it's actually pretty nice. It's not using the original images. We had some old images generated by do we need the images? Right, we have an interactive demo mode. That's pretty good. There's no demo button, is there? It just starts automatically. Which, yeah, we have in our prompt, development prompt. Maybe we can get rid of that instructions because it doesn't seem to work really well. It doesn't seem to work really well. And we'll make it available for you on the site. Everything we do is available on BioniChaos.com. Go check it out, provide your feedback, and I'll see you next time.